If you have followed me up to this stage of learning, I must congratulate you that you are on your way to getting a good score for this topic on kinematics. If you can solve the quiz questions that I've posted on my website below each video lesson, your concept on kinematics should be strong enough to tackle GCE O-level physics exam questions. So now in this lesson, I have chosen a tricky past examination question. So far, you have been learning about falling objects. So what if the object is thrown upwards? How do you solve it? Remember that examination questions are set within the syllabus. So if you apply the concepts you have learned, you will definitely be able to solve it. So let's begin with this question from 2016 GCE O-level examination. A student stands near the edge of a cliff. He throws a ball upwards, as shown in figure 2.1. The ball rises vertically a short distance and then falls. Air resistance is very small as the ball moves upwards. You are required to fill in the table on the magnitude and direction of the acceleration as the ball moves upwards and when it reaches the highest point of the motion. Now, how do we apply the concept that we have learned for falling objects on this ball that is being thrown upwards? We know that if a ball is falling, its velocity increases because the force of gravity pulls it downwards. Its increase in velocity or its acceleration is a result of the force of gravity that has a direction that is pointing towards the center of the earth. So the direction of the acceleration is downwards. When we throw a ball upwards, the ball starts with an initial velocity that is not zero. Once the ball is released, the only force acting on it is the downward force of gravity. Hence, its initial velocity will decrease as it travels upwards until it reaches zero at the highest point because the force of gravity retards its velocity. Its acceleration, that is a result of the force of gravity, has a downward direction even though it is traveling upwards. If the air resistance is very small, the magnitude of the acceleration is 10 meters per square second because this acceleration is due to only one force, the force of gravity or its weight. In other words, if the air resistance is very small, as the ball moves upward, it experiences deceleration or negative acceleration where its velocity decreases by 10 meters per second every second until it reaches zero at the highest point. Hence, this is the answer. In the second part of the question, a displacement time graph for the first 1 second of the motion was provided. It was stated in the question that air resistance is very small in the first 1 second of the motion, and students are required to sketch the velocity time graph for the first 1 second of the motion. You may want to pause this video to try it out on your own before proceeding to listen to my answer. Now for this question, we are told that the air resistance is very small in the first 1 second. If the air resistance is very small, then there is only one force, a downward weight, that is causing a negative acceleration or a deceleration on the ball. This negative acceleration is the acceleration due to free fall, which is a constant. We have learned previously that for acceleration that is constant, or also known as uniform acceleration, the velocity time graph must be a straight line. For a straight line graph, only 2 points are needed for the graph to be sketched out. The question states that the initial velocity is shown by the point labeled A. So this is the first point. Now, which should we choose to be the second point? Let's study the graphs. Since the initial velocity is labeled A at time t equals 0, then that must be where the ball was first thrown upwards, and it corresponds to 1 meter from the origin according to the displacement time graph. The origin is likely taken from the ground at the top of the cliff since it is about 1 meters below. So the end point of this displacement time graph is when the ball passes the top of the cliff. As we do not know the velocity when the ball drops past the cliff, this is not a good point to choose. Next, we look at this highest point, where the tangent to the graph is a horizontal line. The gradient of the tangent to the displacement time graph gives the velocity of the ball. A horizontal tangent means the gradient is 0, and that means the velocity of the ball at this point is 0. Now, this is a good point to choose in plotting the graph because we know the time is 0.4 seconds and the velocity is 0. So with these 2 points, we can easily sketch out the velocity time graph. In part C of the question, you are required to state how the displacement time graph given in figure 2.2 above shows that the terminal velocity is not reached in the first 1 second. Your answer to this question must demonstrate to the examiner what you understand about terminal velocity. So this is how you should answer. If the ball is traveling at terminal velocity, the ball's velocity is constant and it travels the same distance with every equal interval of time. Its displacement time graph will have to be a straight line. Since the displacement time graph in the first 1 second is a curve with no section that is a straight line, there was no constant velocity, and hence we can conclude that terminal velocity was not reached in the first 1 second. The second part of C states that the ball continues to fall. The effect of air resistance becomes significant and the ball eventually falls at terminal velocity. Describe the velocity and acceleration of the ball as it falls at terminal velocity. This is a simple question. You can state that at terminal velocity, the ball's velocity is constant and its acceleration is 0. With this, we conclude this course on kinematics. I would like to congratulate you for having mastered 15 important concepts in kinematics, solved 16 quiz questions, and having attempted paper 1 and 2 GCE O-level questions. You should be able to do very well for this topic. With this, I wish you all the best in your examination and a great future ahead.